Hello, and welcome to week 24 and episode 24 of The Message from Deep Space. I'm Alex Rose, aka Safety Dad. And last time we got some fun words for cosmic masses. Trying to think of a better word there. Cosmic objects, cosmic bodies, heavenly bodies. Heavenly bodies is the word. The pair of words. Um, we got to talk about the planet that we're from, that's Earth, in case you're watching this in the distant future and that's maybe different at this current time. We're from Earth. We had to name a few things. So we got Matar, which is the meteorite star, and we got Doppler, which I have named after the very cute Doppler and Akers. Hello, Akers. And that means that Batista Collins and I are up for some naming. So if we have to do a spaceship or name the person that we're talking to, it's going to be after one of us. We also got left out with a pretty interesting, a little bit scary message. So we have Star Destroy and the alternative, and there's a count that is greater than 3. So there's Star Destroy Alternative 0, Star Destroy Alternative 1, Star Destroy Alternative 2, and then it keeps going on and on. So this suggests to me that there are many different things that either a star destroyed or that could destroy a star. And I'm not sure I'm super jazzed about either of those ideas. So we'll do their pass through for now, but they might be about to tell us something scary. Okay. So this is a name for a star destroy alternative. So we might be about to talk about the ways that a star can be destroyed. So there is, I believe, a supernova and a black hole and a collision with another star and a white hole. Those would be the four that I am familiar. Oh, and I guess there is uh, just failing to achieve fusion. What is that called? Akers, it's your time. So stars. What happens when a star stops doing fusion? Okay, it's not under stars. It might be under. Okay, so we have these four here. Neutron star is probably what this is. Uh, it is a celestial body that has a collapsed core and it is condensed to a small body around 10 kilometers in diameter, which is that is really small. I did not know that neutron stars were that small. I guess that helps explain why that one that spins like 10,000 times a second is spinning that fast. So these no longer undergo fusion. So we're gonna name this neutron star. Um, it might have a name that is the action, but they told us that this is a noun. So we are going to go with the noun. I don't know why I answered neutron star. Okay, so star zero is fusion. Is not if star zero stops uh achieving fusion, then star zero is not a star. Therefore, star zero equals neutron star. Typos. We want to just send a 0. We're overcomplicating it. I always am overcomplicating it. That's one of my best and most easily accessible skills. All right, what are you drawing for us? Is this going to be a sphere? Okay, so neutron star and something equals this cluster. So I'm going to assume that this really small one is the neutron star, and therefore this is a normal star. No? Um, neutron star and what do we have words for? What are they asking for? Is there something that's specifically associated with a neutron star? Uh, I guess neutrons. We do have a word for. No. Okay. Uh, well, what do you mean then? Do we have a word for just a planet? We have all planet, which is a planetary mass. Um, we can answer their star. We could talk about an orbit. What are you asking us about? Okay, so we have a big white sphere, and we have a small blue sphere. I believe neutron stars are typically thought of as blue, which is why I think on top of the size that small one is the neutron star. Uh, so they rotate at high speeds, consist of neutrons, no longer undergo fusion. Um, I guess the big white one could be a white dwarf star, but we don't have a name for that. So so what? So what is this? Um, because I feel like they're asking for maybe a moon. We have words for moon, and neutron stars would be smaller than moons. No, I mean, my guy here is to just say different celestial bodies that we have names for, and hope that one of them is right. But I don't love brute forcing it that way. I feel like I should be able to know and figure out what this is. Um, so are they perhaps asking for more than one word? So there's definitely only two spheres here. We can see that. But what do we know about this second sphere? We know that it's bigger, and we know that the colors are different. We already went over those. Um, if anyone has any other ideas, then I don't. I'd love to hear them. Anybody want to chime in? Um, Maybe if we look at our previous transmissions, that will shine some light on the matter. Let's see what the context is. Okay. So, did we use an and here at all? No. Um, so it's asking for. I'm pretty sure it's asking for what the second thing is. And it has to be in words that we already know because they're not giving us a new word. Um, uh, maybe this is the star that it used to be? Um, we don't have a word for before. I'm really stuck on this. I really don't feel like I should be this stuck here. Maybe star not destroy. Like a healthy star. Star 0. Um, not neutron star. Gah! Okay, what do you want me to know? Um, you want to talk about the different ways that stars are destroyed. You want to establish something about a neutron star. Um, you want to we want us to demonstrate that we understand some aspect about the neutron star. So if we look at they rotate a lot, they have a lot of neutrons, they don't undergo fusion. They um, they they what? They lose their planets? Um uh uh I it could be it could be it could be another kind of star, but it can't be. What if we just answered neutron star again? Like this is the neutron star. Um, this is. What do you want from me? What do you want from me? Okay, so a star destroy. One of the ways a star can be destroyed is to become a neutron star. A neutron star is a noun. Star 0 fusion not with. Therefore, star 0 equals not star. Therefore, star 0 equals neutron star. Uh, the Wait, look, there's a planet. Does it destroy the planet? Um, and we don't have a word for planet. We just have a word for the two specific planets. I'm losing my mind. Um, this is the craziest I've ever felt in this game. There's so little in the message. It's just this and something uh equals something else. Um, okay, going back to our dictionary. We've answered Matar. We've answered. Could we say a fusion star? Um, Perhaps a star with fusion. How did they phrase that before? Um, and star fusion. With. I don't know. Um, okay. Um, 10 kilometers across for the average neutron star means that no planetary or heavenly body that we're talking about could be that small, except for like a meteor, maybe. Um, hmm. You know, it might be time to turn to the Discord. Uh, I have been really enjoying peeking in the Discord of the acts that I've already taken a look at. Uh, but I'm not sure that it. No, I don't. I don't know that I should. Um, hmm. Okay. I'm massaging my temples. I'm activating my Jimmy Neutron brain, my Jimmy Neutron star brain. I'm trying to procure brain blast. I'm trying to intuit the sine waves that it wants. Um, and I think it wants star, not destroy. No. Okay. Um, and star destroy alternative one. No, I really thought maybe I had it with that one. That maybe that they were gonna talk about the neutron, the supernova or something. You know what? We're just gonna check to see if it's one of these other ones. I don't feel like they would jump to 2 or 3, but I'm gonna take a little break. I'll be right back. Okay, I am back, and I was looking at my dictionary. I was trying to come up with anything, and I am stupid. I realized that we do have a word for planet specifically, and I just thought we did. Okay. Oh man, I spent so much time trying to figure it out. Okay, so we're saying another way of destroying a star that doesn't have fusion but has a greater mass than a neutron star. Um, is this a white dwarf star? Uh, yes, I believe it is. Uh, so that is our white dwarf star. Proton count is greater than electron count. Add. Neutron. This is our neutron star. The other one was our white dwarf star. I get overzealous. Um, because this is saying that the neutron count is higher than the electron or proton count. Um, so something and two planets. Okay. Okay, yeah. So that's a small star. 10 kilometers still feels really small. So, but it's enough to move on. We're good. Okay, let's go over one of the other ways that a star can explode. Or actually, they haven't exploded in either of the ways we talked about so far. But one of the other ways that we can be a star can stop being a star. Okay. So in this one, it doesn't have fusion, and mass, the volume divided is greater than a neutron star's volume. So, black hole? Black hole, maybe? So far, the colors for the stars have also been somewhat hint-ish. So, that that feels like a black hole to me. Uh, which I feel like the last one to talk about then is a supernova. This word is no. We're not going to talk about the supernova. We're going to talk about a measurement of some kind. So we have this new word. It's a noun, and this noun applies to or comes from stars, planets, moons, white dwarfs, neutron stars, and black holes. Aliens, something here. Star count is 1. Round to sig fig equals. Uh, they're counting. Oh, this is how many stars they're counting. Uh, no, wait. this is okay. Wait, this is how many? Is this how many of each of these things there are? So like if we go to our reference manual and we take a look at uh, the amount of black holes that there are, is that so that they're asking us to count what? Um, so they're saying that there's the aliens something planet count is rounded to 1 sig is 8 to the power of 13. Oh, it's fun that they use 8 instead of 10 because that's their 10 because they're in base 8. I didn't even think about that. That's cute. Um, okay. Maybe their galaxy? Oh, it's because a galaxy would consist of stars, planets, moons, white dwarfs, neutron stars, black holes. And the aliens would say that this, like, a galaxy's star count could equal all this. Um, Now, we don't know. Uh, oh, um, so they're giving us like a recipe for the galaxy. So they're saying that many things are in a galaxy. No? It's hard to fathom the scale of a galaxy. Even for you, someone who has studied the Milky Way in such detail. The more I study, the more I struggle to fathom it. Okay, well, Akers commented on it, but it was still wrong. Perhaps universe? Well, no, because then this would have been right. It just would have been right for the wrong reasons. Okay. So it's something that is made up of this. Um, so it's weird to have two equal signs here. What is it asking? We have recipe, right? Is it their galaxy recipe? No. Um, okay. All right. Yeah. So what other stuff do we? I think it's reasonable. Oh, it's not just a galaxy. It's the alien galaxy. Uh, okay. Or it could be Galaxy Zero. No. Um, it's how have we used the word recipe before? I know we've used it. Um, Maybe Galaxy make with. Okay. They probably wouldn't make the syntax too complicated here. It's not worth it. So this is a list of some things that go in a galaxy, um, including their star count, their planet count, their moon count, their black hole count. And then some greater equation. One stuff that goes into one galaxy? No. Um, does it want all of them together? Does it want I if it if it wanted it all together, then I feel like there would be an ad, but maybe there's not. So the way that this would look to us is they have 8 the power of 13 times 1, 2, I guess just times 2. And that's a big number. Uh, and then I guess, but this would be, could we say like 16, 14 exponent? No, we're not even including all the data there. It doesn't just want us to do the last one, does it? No. I'm trying to describe a number of galaxies. I don't like this one. No. This section has felt probably the most syntactically hard because it has felt the most unclear what they're asking of me. But okay. Um, I don't know. Is it true? Are they? Is that a true fact that they're telling us? No. Gosh. So syntactically, they're saying this goes into a galaxy. That their galaxy star count is 1. Or rounded to a 1 sig figure is h to the power of 13. I don't know what it wants. Uh, 8 to the power of 9. I don't know. This would equal the last thing it told us. That's stupid. I don't like that. That's the only transmission so far where I genuinely feel like pissed off. Okay. They are drawing something odd here. Oh, they're drawing the Milky Way, I think. Or Andromeda. They're drawing a galaxy. They're drawing their galaxy. Uh, okay. Are they trying to say that their galaxy is our galaxy? It is. We're in the same galaxy. That's nice to know. That narrows down the search. Okay. Acres, they're speaking your language. They're dividing things into metallics and non-metallics. Uh, so alien star consists of metallic atoms. So alien star collection 1 atom count. Alien star. Okay, so this is the ratio of their metallics to non-metallics. Which Acres, you're always going on about this. Don't you want to talk about this? Hey, these aliens think like us. They think like us? What do you see? Oh, no, not like you, but by us, I mean astronomers. All they care about is hydrogen and helium compared to every other element. On the topic of stars, maybe, but who knows how they think of or acted in other disciplines. Hey, let me have my win. And they're telling me the metallicity of their star. That feels like an important step to figuring out where they are. Dr. Akers, you mentioned metallicity. Is that correct? Yep. Which measures how much of a star is not hydrogen and helium. Right on. So what is the metallicity of the sun? It's a population of 1 star, which means it's metal rich. So fairly high metallicity, it sounds. More than the average, our big beautiful sun is young and rich, which is good news for us. Why is that? If our star didn't have so much metal, then our planet wouldn't have so much metal. Which means there less carbon, less oxygen, and less iron. Imagine it would be far more difficult to build things if even common elements like iron were rare. Ha, you could say that. What's your takeaway? Well, if our planet didn't have that much metal, life may never have started. We could have never existed. I wonder what their relative metal is. I would gather that that's something that Akers is going to comment on. So Matar's orbit is 1.8 times 8 to the power of 13 alien light seconds. And their path, their alien, what? Multiply alien light seconds, and that's greater than, oh no, that's not greater, that's close parentheses. Why not just say orbit? Matar target galaxy orbit width. Oh no, okay. This is their radial distance from the center of the galaxy, which should narrow it down. Okay. Aliens target meteorite 0, make width. Doppler origin, Earth, destination. Meteorite 0, move width. Right, so the idea is, so I said idea because it popped up over here. So the meteor moved from Doppler to Earth. Doppler origin, Earth destination, distance. Matar galaxy distance. Matar mass. Matar volume. Matar metallicity metals count. Matar planet count. Doppler mass. Doppler orbit time. They are telling us a huge amount of information here. But humans target meteorite 1, make width. So we make a new meteorite, and then it's the origin, and Doppler is the destination. They want us to make them a meteor. They told us that before, but they're reasserting that, and they're telling us more details about where they live. I didn't see any numbers there, but... team, have we learned where they call home? Yes. What? Are you sure? We're positive. How? How'd they communicate that? Would you like me to keep it brief? Or would you prefer the long story? Brief. Tell me everything. Well, it started about 100 transmissions ago. We defined atom, which we used to describe isotope and half-life. From there, we finally had a unit of time, 0.806640625 seconds. The second. Exactly. Then they defined think velocity, which we could use to derive a distance unit. And so you got, let me see here, alien light second and alien meter. From there, we're able to define other units, such as mass, using an atom, the all group, and the all planet by duplicates. Different units are useful for different contexts, just as we theorized. Have we learned of those different contexts? Outer space! They're celestial scale units. And with a bit of grammar defined, we're able to define celestial bodies. They describe their star and planet, give us a list of identifying information. Details to their home, I see. We also use the speed of the meteor's travel and the time elapsed to ballpark the distance between us and the aliens. So where do they live? That's the rub. We're not sure yet. I've run the data through various stellar catalogs until something pops. Then go do that. That was my plan, but it means I'll need to take some time away from the translation team. Alan! Oh. I know. You guys will miss me. But don't worry, I should be back soon. We've kind of like thousands of stars. I'm sure I'll find theirs. But enough of that stuff. I don't want you all to cry too much. Continue the translation without me. Though I know that'll be tough with your world-class astronomer. We'll miss you, Alan. Best of luck, team. I'll be back soon. Good luck, Dr. Akers. Come back soon. Best of luck. Akers, we're gonna miss you. Can't you get another scientist to look this stuff up? It was a hard 12 transmissions. Okay. Alan Shrill. Status? Excited. I have to say goodbye for now, but it's what I've got to do if I want to one day say hello to my friends from quite far from here. Batista's log. Alan is leaving. I wonder when he will return. Aw, Batista. Dear Diary, I knew the numbers would build to something. They unlock geometry, information, and logic, which have guided us to describe the meteor and atoms. Then we can describe our two worlds and the universe we share. It's beautiful. But I can't help but wonder, where will the transmissions lead us now? What topics of discussion remain on our intergalactic table? Dr. Akers is setting out to find where they call home. I wish him good luck. Best of luck. Wish him the best of luck. And to the temporarily 3-member translation team, I wish them even more luck. Godspeed all. You're gonna miss Akers. But it was really cool to hear where the aliens are from. It was way more of a pain than it needed to be. Yeah. A bit of a late night for me. Oh, that's the end of Act 5. Very exciting. So, see you guys in Act 6. As always, if you enjoyed, don't forget to like and subscribe, and I will see you in the next one.